Let's study 10th Standard ICSE Chemistry Chapter 4b, Type 1 sums, that is percentage composition. We hardly have any theory in this chapter. It's mostly numericals of three types. The first type is percentage composition. Only three definitions have to be learned for this chapter. Cancel the first two sums. They're pretty easy, similar to the ones you've solved in 9th Standard. You may do it for practice. But let's start with the fourth sum, which is a little advanced. Calculate the percentage of pure aluminum in 10 kg of aluminum oxide of 90% purity. So we have bauxite, out of which 90% is aluminum oxide and the remaining 10% is impurities. So the molecular weight of aluminum oxide is 102 gram. Typically, if they would have asked us the percentage of aluminum in this, we would have simply done 54 upon 102 into 100%, which would be slightly more than 50%. But no, they want us to find the percentage out of bauxite, which has impurities too, which means that the percentage of aluminum in that would be less than expected. A short method is find the percentage of aluminum in this, which will come out to be 52.94%. But this is only 90% of the bauxite. So the percentage of aluminum in that would be 52.94% of 90%, which will give you the right answer of 47.64%. That's a short method. But let me teach you a longer method. First of all, 90% of 10 kg is 9 kg. Let's find out of 9 kg, how many kg is aluminum. Unitary method. In 102 gram, we have 54 gram of aluminum. So in 9,000 gram, we will have how much? Turns out to be 4.764 kilogram. So out of 9 kg, we have this much of aluminum and the rest is oxygen. So out of 10 kg of bauxite, again, we have this much of aluminum and the rest is oxygen and impurities. So what is the percentage of aluminum out of this? Well, it will be this upon this into 100%. We won't find the percentage of aluminum in aluminum oxide, no. We will find the percentage of aluminum in bauxite, which has impurities. That is why the percentage drops down to 47.64%. Now the sixth sum is also exactly like that. One correction, it's not carbon carbonate, it's calcium carbonate. And here they have not given the mass of 10 kg. So you can take it as 10 kg or even 1 kg. Your choice. So we start off with the GMM of calcium carbonate. Now clearly carbon has a percentage composition of 12% out of pure CaCO3. But what is the percentage of carbon in impure CaCO3? That's what we have to find out. Yeah, you could have done 12% of 55%. That would give you the answer straight away, which is 6.6%. That's a shorter method. And the longer method is, same as earlier, let the impure calcium carbonate be 1000 gram or 10,000 gram. You can take any value, any multiple of 100. Out of that, 550 gram is calcium carbonate. Out of 550 gram, how much is carbon? Cross multiply and get the answer. Turns out to be 66 gram. That means in that 1000 gram of impure calcium carbonate, we have 66 gram of carbon. So we'll find the percentage, which comes out to be 6.6%. And now the eighth sum. Hydrated calcium sulfate, CaCSO4.XH2O. X is unknown variable, so we don't know how many molecules of water crystallization are associated with each molecule of calcium sulfate. But we do know the percentage is 21%. So let's find out the number of molecules here. First of all, we'll find the molecular weight of calcium sulfate hydrated, which comes out to be 136 plus 18x. Now the percentage formula is the mass of the water upon the total mass into 100%. Percent cancelled. Percentage is given as approximately 21%. Mass of water, x molecules of water is 18x, and this is the total mass. Further calculation, well, this can be cut 3 7s are, 3 6s are. Cross multiplication, this goes up, brackets, open the brackets, 600x here. X's together, and this is 474x, 474 goes down, you get x alone, which is approximately 2. It's actually 2.00 something, but number of molecules cannot be decimal, so we stop here and write the final answer in English, that the number of molecules of water crystallization in the hydrated compound is 2. Nishtha, you forgot that. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.